In this video, we're going to be looking at acidic solutions. We'll talk about what is a strong acid versus a weak acid, and why do we call them strong and weak. And then we're going to look at how we can find the hydrogen ion concentration of a given strong acid solution. Before I move into the acids, let's remind you about pure water and aqueous solutions. We know that in both pure water and in any neutral solution, that means something with something like salt or a covalent compound dissolved in water, those are our neutral solutions. We know that in all of those cases, the hydrogen ion is equal to the hydroxide ion, and that the hydrogen ion concentration times the hydroxide ion concentration will always be 10 to the negative 14. So if we know hydrogen, we know hydroxide. But that is true for all of our aqueous solutions. Hydrogen ion times hydroxide is equal to 10 to the negative 14. So that will be true in our acidic solutions and our basic solutions. But in acids and bases, the hydrogen ion and the hydroxide ion are not equal to each other. We are going to look at aqueous acid solutions next. That is when there is more hydrogen ion than hydroxide ion. We've added extra H+. When the acid reacts with the water steals the hydrogen atom and leaves behind the anion. At this time, it forms a hydronium ion at the same time. The anion that's left is the same at the start and at the end. They will be the same anion. If it's acetate, it's acetate. We're going to simplify that by writing HA forms H plus and A minus, where, of course, the anion is the same. For example, if I have hydrogen fluoride, I will make hydrogen ion and fluoride ion. Now let's look at acids. Acids are substances that ionize in water to form hydrogen ions. Next, we're going to ask about what does it mean to be a strong acid. The strong part of it means that it ionizes completely. 100% of it turns into ions. There are 6 strong acids that you need to memorize. No way around it, you must memorize these. The first 3 are HCl, HBr, and HI. These are halogens except for fluoride. Just remember, if you have an F, you're weak. The next 3 are hydrogen sulfate, hydrogen nitrate, and hydrogen perchlorate. You need to be especially mindful of the number of oxygens on each of these substances. It is always the one with the highest number of oxygens. Now we're going to focus on some calculations. We're going to move letter C down because I don't want to focus on it yet, and we're going to give an example where we're going to try 100 particles of HCl. In this example, we're going to look at what it looked like before and after it reacts. If we have 100 particles of HCl and we have no H plus or Cl minus before the reaction, what do you have afterwards? Well, afterwards, you have no HCl left because 100 reacted, and we have all of it turning into H plus and Cl minus. Notice that these two are the same number, and they are the same number as what we originally started with here. We know this because we get one hydrogen atom for every one anion, and that all came from one acid molecule. What if we had started with 40 molecules instead of 100? That means that we have 40 particles of HCl to start with, and we have no hydrogen and no chloride. So what do we have afterwards? Well, if 100% reacts, we have no HCl left afterwards. All of it is turned into H plus and Cl minus, which will now be the same number we started with, which is 40. Now we can go back to our original example of 1 liter of 0.1 molar HCl solution. Let's see how we solve for the hydrogen ion concentration. When we are solving these types of questions, there are 2 things you must look at. First, the first one is whether this is an acid, a base, or a neutral compound. Throughout this section, I will be notating that as ABN. The second step is to identify whether the given compound is strong or weak as an acid or base. So let's look at our question. We have 0.1 molar HCl. Step 1. Is this an acid, base, or neutral? Hopefully you could identify this as an acid. Because it's an acid, that means it tells us the hydrogen ion directly. So we see here that it's going to tell us the theoretical hydrogen ion concentration. Now we look at part 2. Is this a strong acid or a weak acid? This one is strong, so that means that we will know exactly the number of the theoretical hydrogen ion concentration. So now let's put that in our chart. How much do I have to start with? I have 0.1 molar HCl. How much H plus? I don't have any. How much Cl minus? Again, I don't have any. After the reaction, after the ionization reaction, I will have 0 HCl left, and I will have, in this case, 0.1 molar H plus and 0.1 molar Cl minus. The only one that I really care about is the H plus because that's what the acid is. We're being asked what is the molar concentration of this strong acid, and the H plus will be 0.1 molar. We normally write that in exponential form, which would be 1 times 10 to the negative 1, or in this case, just 10 to the negative 1 molar. Now, let's find the hydroxide ion concentration. Recall that in aqueous solutions, hydrogen times hydroxide is equal to 10 to the negative 14. When we solve for hydroxide, we divide both sides by the hydrogen ion concentration, and we find that the hydroxide is going to be 10 to the negative 14 divided by the hydrogen ion concentration. That means in our example, the hydroxide ion concentration is equal to 10 to the negative 14 divided by the hydrogen ion concentration, which is 10 to the negative 1. And in our case, hydroxide ion concentration is equal to then 10 to the negative 13. Now let's try 0.001 molar HBr. Here's what we're working with. This is the HBr. On yours it says HCl. Okay, what is step 1? Step 1, acid, base, or neutral. We see here that we have an acid. That means that it will tell us hydrogen ion directly. And step 2, is it strong or weak? In this case we have HBr, which is strong. So that means this number will be equal to the amount that we originally had. In this case, that answer is 0.001 molar, or 10 to the negative 10 to the negative 3 molar. Now that we know the hydrogen ion, we can find the hydroxide ion. And that will be equal to, our 10 to the negative 14 divided by the concentration of the acid, in this case 10 to the negative 3, and our answer will be 10 to the negative 11 molar hydroxide. Let's try one more. So let's try 0.00001 molar HNO3. So step 1, acid, base, or neutral. We see that we start with H, so this is an acid. That means that we know hydrogen ion directly. Next we have step 2, strong or weak. Hopefully we know this one as a strong acid. That means it will be equal to the number we started with. And that number is 0.00000. That's 1, 2, 3, 4, 5 zeros after the decimal, then a 1 molar H plus, which is 10 to the negative. We start from here. We go 1, 2, 3, 4, 5, and 6. 10 to the negative 6th molar in hydrogen. Next, we find hydroxide ion concentration. And that one is going to be the 10 to the negative 14 that we've used before, divided by the hydrogen ion concentration we have here, which is equal to 10 to the negative 14 divided by 10 to the negative 6th, and that is 10 to the negative 8th molar in hydroxide.